everyone. Welcome everyone to this webinar about Dodona. So we have our three speakers today, Peter, Bart, and Lieven, to talk about how Dodona came to the world, so to say, what it does at the moment, and also then later on some testimonies, I think, about how Dodona is used in daily practice and in courses now at the universities. So I hope everyone is okay to record the session. We can later on decide then if we and how we distribute it. Anyone against it, then please open the mic. Okay, good. Then I'll leave the floor to gentlemen from Ghent, and I'll leave it to you. Who starts first?
Okay, thank you for the kind introduction, Alex, and thank you, Alexei Yasmin, for the invitation and giving us the opportunity to present Dodona to the Elixir community. We had in mind to have like three parts, so I'll start with a quick tour around Dodona to get you an idea of what Dodona is about. And then Professor Lieven Clement will come in to show how he has bootstrapped his statistics classes with basic R skills training for his students. And then Bart, Professor Bart Mesuere, will end our part with some more advanced features of Dodona. So that will take 15 minutes each. That should give us 10 minutes at least to have a Q&A session at the very end. But the chat is open for everybody. So if you have any questions in the meantime, Bart can answer questions while I'm doing a tour in Dodona, and reverse. I can join the chat when Bart is giving a presentation or when Lieven is giving a presentation. And now that we're used to online teaching, I can actually also use questions from the chat while I'm giving a presentation. If anything comes up, just throw it in the chat. Makes it a bit more interactive. So let me start with a quick tour around Dodona. Maybe I'll show one slide to give you an idea of the team behind Dodona. Bart, when he was still a postdoc in my team, and I started Dodona, I think in 2015, at the very end of Bart, his PhD, to support my own programming classes. We actually officially launched Dodona in 2016, but for 3 years it was a project that was held within the walls of Ghent University. But in 2018, we opened it up to other universities, secondary schools, and so on. But we always worked with a small team. So for the first few years, it was only Bart and me. So the current team is 3 PhD students, 2 who will graduate or hope to graduate this year, and then Jorg, who is a full-time developer. So if you look at the history, we're now at the cool situation where we don't have to do all the work ourselves, but the team is a bit bigger, and having like a full-time developer, which we support from different research projects, is very helpful, given the fact that the power of Dodona also comes from the community. So Dodona is now much more than just a platform. If I just show you some statistics that you will also find on the login page, you will see that we are now in more than 1,500 schools and universities. So that means a lot of teachers, a lot of students. For example, we develop the platform, but we don't develop the content. Well, we develop content for our own courses, but you see there's close to 17,000 exercises going from HTML or databases to statistics or programming, just the basics, but also to much more hardcore computer science and data science courses. So that's the true power of the platform for me lies in the open infrastructure and the community of people using the platform, but also contributing content to the platform. So I hope I will give you a bit of that feel, and then Bart, for example, will also show you how you can contribute yourself, how you can use the platform, but also at the same time how you can contribute to the platform. My tour will be two parts. So I will start from the perspective of a learner, of a student. So what does the platform bring for a student? Because students can actually follow courses or work on their own skills, self-paced, or in a more traditional classroom environment. And the main asset of Dodona is that when they work on their skills, they constantly get automated feedback. You see that Dodona has received 17 million solutions so far. No way this is something that our team does by hand, by giving feedback to all of the submissions. This is done all automatically, and this was already this automated assessment. This is where Dodona was built. So students can also follow their own progress. They can work on different skills. They have a kind of a self-evaluation. And then from the perspective of the teacher, teachers can set up courses and can let students work in these courses, follow up students, organize exams, also with automated assessment, also with support for evaluation. So I hope I will give you a little feel of that. There's much more in the Dodona that we can cover in 1 hour, but just getting started is actually quite simple. And I hope we will give you a feel that the main driver for the Dodona, or from us developing the Dodona, is to remove everything that is a friction, both as a student in learning. And so what is the best possible way to learn? This is one goal. And then for teachers, we want to avoid friction, because if you have large classes or students working at different times and you have maybe even different places, how can you supervise all these students if you still want to give yourself a good night's rest? So try to automate as much as possible, both for the students and the teachers. This is the ultimate goal for the Dodona. It actually already starts when signing in. So when signing in, from the very beginning, we decided we will not manage our own accounts in Dodona for a couple of reasons. First of all, as a team, if you have to manage something, it takes you time, but also for trust. If you use a platform to organize exams or tests, high-stake tests, and students can, for example, use their Gmail account. The Gmail account does not give you a lot of trust as a teacher about the identity of the user. In Dodona, you can log in with a Google account, but students can also log in with their institute account. So if you say I'm in a university or a research institute, you can actually use those accounts and give access to certain parts of Dodona through those specific accounts. For example, if you come to an exam at Ghent University, you have to authenticate yourself through your Ghent University account. So it's very open-ended. We can extend authentication to different platforms. We have some general things, and Microsoft accounts and Google accounts are in there by default. We also have, of course, the Elixir accounts that can be used, but also very specific institute-specific accounts. This is all a possibility. So I will just log on with my Ghent University account. Then Dodona knows that I'm a teacher, and I get to see my own courses that I'm organizing. So this is just my landing page. And just for simplicity, I will choose one of the courses that I have been teaching in the first semester this year. So it ended with the exams in January. You see, it's a class of 600 students who have to learn program for the very first time. So as a teacher, this is quite a challenge to have like a new group every year learning these skills. For most students, and we have students coming from biology, physics, chemistry, so no computer scientists. So learning to program for some is very easy because they already learned it somewhere else. For some, it's pretty hard. So you have a very diverse group, and you have to try and bring them to a certain level. You also see the load for a teacher. So those students in the months of October, November, December, and then the exam period in January have submitted 318,000 submissions. So no way as a teacher I can do this by hand. if I would do the hand correction for all these submissions, it would take the team more than 13 years for just one single course. So this is the scale of feedback that we can provide by using automation. If you look at the structure of the courses, this is something that students see. This is now my teacher view, but apart from some statistics and some management operations, students see the same thing. So a course is just a learning path with some series. Series can have a deadline. So for example, this is the first programming topic, working with variables, expressions, and statements. Just some preparatory work for the students, some extra exercises. But in my course, students have to finish these 6 exercises by the end of the first week. So you see there's a deadline. This is the target. So students can actually submit solutions to these exercises. I will take these exercises just to give you a feel. And I have a solution somewhere in my IDE. So students work out a solution. So this is a very simple exercise. It asks to give 2 integers and then compute the sum of the 2 integers and print it to the screen. So this is the very first example that we give. So students program in their IDE. And then, for example, I want to now just copy paste the solution into Dodona. And Dodona will now take a second or so to test this solution. So this solution goes through a whole bunch of tests, and students get all the feedback in those tests. So the goal here is to provide as much feedback as we can. And maybe it's more interesting if we just screw up the solution, because of course students don't initially get a correct solution. And so there's a couple of features built in the platform and to show students that this is not a working solution, but also to help them out to find where the possible mistake is, correct that mistake, and resubmit. And so there's no limitation how often students can submit a solution for this assignment. They can even submit after the deadline. The deadline also only is an agreement that if the teacher sets a deadline, usually it will only take into account the last submission before the deadline, for example. So this is a very simple exercise, but you immediately see all the tests fail. Just to give you an idea of how we remove friction. For example, this is another exercise. Instead of like copy pasting solutions to the platform, and this is the nice thing, the platform is open source completely. It's also free, so everybody can use it freely. Some of our own students have written plugins for IDEs. So there's a plugin, for example, for Visual Studio Code. Here I'm working with PyCharm. So there's a plugin that removes the need to do copy pasting. So I can just take my solution and submit it to the platform. It will take a couple of seconds. And again, I get the feedback that this is a correct solution. Again, if I click here, I can open my browser, view the results, and I see the results. So I can actually stay in my IDE if it's correct, but if there's a wrong solution, like do this once more with a third example. This one is a wrong solution. So if I submit it, the only feedback that my IDE will show me, it's an incorrect solution, but I can actually inspect the results. This is an exercise with 3 functions that students have to implement. The first 2 are correct, but the third one has 30 failing tests. You even see you can actually write exercises with some visual feedback. In this case, it's just curling, and you show the curling board. Students have to calculate the scores. But the feedback can be textual. You see that there's an automatic diff. So to highlight the score that was computed for the red team was 2. But the score is actually determined by the number of circles closest to the center. So there's one red circle closest to the center, but then the next one is yellow. So the red team wins, but only with one the correct answer. And maybe I should switch to English. Then you will also see the feedback in English. Here, there's the expected output is 1. But the code actually generated for this test case a 2. Other things that help students, for example, if you have a failed test case, you can immediately start a debugger with the code and the test case, and it's a debugger that is tweaked especially for newcomers. This is a time-of-flight debugger, so you can actually move through the code forward and backward. Because what we know from software development is that you have a failure, so where the code actually fails and where you see that it starts to behave differently, but you also have a bug. So usually you have a bug earlier in your code than where you start to see the phenomenon. So with a traditional debugger, you can only go forward. So you pass the bug, and at a certain point in time, you see that something goes wrong, but you cannot go back. So one of the advantages of this debugger is that it also allows you to go back in time, and it's also very visual. So all the data structures are visually rendered. So you see that in this case, it's like a couple of lists that you see, for example, how aliasing works. And so this is what I meant when I said we try to help students as much as possible in the learning process, showing them clearly where they have mistakes in the code. And they can also program here. This is a Python IDE. You can actually, it starts read-only, but if you stop the debugging session, you can now actually start to spot the mistake. Of course, there was a +1 here, and now I can run the doc tests. There were tests in this code, and now I see that after changing this mistake, I just resolved the issue for a couple of tests, and now I can just submit again to Dodona. And so that's how the flow works for the students. On top of that, students can follow their own progress. So here I had a wrong solution. So let me correct this one. This was the +1 because the wrong solution is based on my last submission. So students can fail. You can learn from your mistakes. But after that, you will see that all solutions are correct. For the first series, this is also seen by this symbol. And so it gives students an idea where they are, what the deadlines are. Like, deadlines are very important. So on their homepage, they can see for all their courses, the different, if I go to my homepage, for all the different courses, the different deadlines. So this is a course I'm teaching this semester. Next deadline is in 6 days. Students can immediately jump in on exercises they are still working on. For example, never to forget the deadline. There's an option to have like a calendar link for this course, put all the deadlines in my own calendar with an icon link, so I never miss any deadline. Because otherwise, as a teacher, you also have discussions with students that they missed the deadline because they did not know it was only 5 minutes. So we just avoid it this way. So this is the student perspective. Bart will give a little bit more advanced stuff. Lieven will give a use case, but let me briefly show you what Dodona also brings for teachers. So as a teacher, you can also follow up, but not an individual person. Well, you can follow up an individual person, but you can also follow the team. Some things can also be seen by students. For example, here you see the class progress. This is something you can hide for the students, but this shows for a given exercise. If I just go to the course that I'm giving this semester, this is a Dutch course, so there will be a lot of Dutch here. So this is series with deadlines that have passed. So if I go to week 5, so this is still something students are working on. Here I can see if students start suffering with one exercise, for example. There's a lot of students that started this exercise but then did not find the correct solution. Maybe this is something we can use in hands-on sessions to spot what is the particular case they are running into and give some additional explanation. So the platform Dodona is not only to replace teachers, it also to help teachers in the process. There's also value of having like hands-on sessions with students and have direct talks with them. But for most of the students, it does everything automatically, but as a teacher, you can follow up. So there's a lot of learning analytics. Bart will show you some more. For teachers, again, you can follow everything from different perspectives, from a perspective of an exercise for all the students or for a single student. You can even take tests and the support for tests to have like a combination of both automated assessment and manual assessment, because computers are still not good enough to give automatic scores that are reliable in most cases. So as a teacher or as a senior developer, you still see things that linters don't see. Well, I forgot to tell you, but we don't only do tests on code. You can actually do everything. By default, we, for example, also run a linter to see if there are any code smells in the code. Students can also ask questions. So there's a dashboard. Before I do that, I will switch to anonymous mode. So anonymous mode turns all the names of students into pseudonyms. So we don't see the actual names of the students here. So then I can safely show you things in real life. Because if I now show you the class list, all these students have gotten a different name, except for me, because I'm the current user. But these are all non-existent names of students. But I can, for example, this is a course that was finished, but in this course, there were more than 1,000 questions asked by students. And we have a dashboard. We have a dashboard that automatically updates if questions come in. They have a status unanswered question. As soon as one of the teaching assistants opens that question, it automatically goes to the stage where it says in progress. So that avoids that two teaching assistants simultaneously answer the same question. That's all time lost. And finally, if the question is answered, it goes to the answered state. Actually, students can also mark their question as answered, because sometimes students ask questions and in the meantime, they found the answer themselves. This is between 10 and 20% of all the questions are set to the students as answered, either because they find the solution themselves or talk to other students or talk to a teaching assistant. So that's also the interactive process and the community process of helping each other in programming. But you see that this is a student that asked a question on, in this case, result of an exam. And then there's a kind of a conversation between the teacher and the student asynchronously. So online, if students are programming late at night and they need help from an assistant, and they can just ask a question, and then maybe the day after there's a question. Talking about late at night, in Dodona, we also have a dark mode. So light only attracts bugs. So there's a dark mode. If you work at night, you can just switch off the light, and then all the bugs are gone. I told you there are exams you can organize. For example, if I take an exam, I'll take an evaluation here, for example. Oh, so I'm in anonymous mode. So you see that some things are also blurred. That's for an exam, for example, the class results are seen by the students, and also the exam questions are seen by the students. So in order to not disclose exam questions to students or the results of exam questions to students, they are blurred. If you hover over them, you see it. But for example, for an exam or during an exam, I can have a score sheet. And then if I sort it, I can actually see, this is just an exam with one student. Let me take another evaluation here. And so the score sheet allows me to give like an overview of what students already solved. So for every individual student, so the top students here solved everything. There's only 2 assignments and 2 documents. So you can also have like documents to show them, but their status. So if they solved an exercise, yes or no. So you can also use this. If you have a small group to just follow the track of the students individually, you can actually click something and then you immediately dive into that particular solution of a student. Maybe just find that solution in class and just say, okay, but I saw your mistake. Let me help you out. And so this is where we use Dodona for. This is like the static side of Dodona. So when everything is already in there, you set up your class, you set up your course, but this is all something that everybody that has teacher rights can do in Dodona. So if you log into Dodona for the first time with your Google account or your Microsoft account, you will have like a limited account, which is the same account for students. For those here who would get interest in using Dodona yourself, there's a lot of documentation available. So if you go to the sidebar and you go to the user manual, there's a lot of these things that and the advanced things that have been documented. But the important thing is that you have to request a teacher account. So if you go to the contact page, which is the place where you can just send us everything, there's a specific track for, so this form will not show for me because it says that I already have teacher rights. But if you just open this form, it asks you to fill up a little bit of information, which is enough for us to do a screening and then give you teacher accounts. I say doing a screening, this is an important part because teacher rights gives you some power. For example, if you're on an exercise, you can go to the info page of an exercise. And if the author of the exercise has added this to the exercise, there's also solutions available. So this is not something we would give access to students. So this is why we do a short screening if teachers are really teachers. And this allows you to set up courses and so on. For example, to set up a course, you can start from scratch by using these 17,000 exercises that are in the platform. You can also start from an existing course, just copy it. Because a course in Dodona is actually a combination of, it's the learning track, but also a bunch of students. So this is where you track your own students. Otherwise, they are just in a large bunch with other students, but usually you just want to have your particular set of students and follow up the progress, especially for those students. So with that small introduction, I would like to give the floor to Lieven. Lieven is a statistics professor at Ghent University. He's not part of the Dodona team, but he has been giving statistics classes for many years. And then a couple of years ago, he embarked in migrating a lot of his courses into Dodona. So Lieven, if you're ready, you can actually take the screen sharing. And so Lieven will give some witnessing insights on what he did with students as a teacher and what the reactions of the students were. Floor is yours, Lieven.
My screen?
Yeah. Okay.
So what we basically did in 2020, we had an innovation project for submitting the innovation project, and that was very timely because we had like the COVID pandemic that struck us. And the main idea was that we faced the problem that students that are following statistics had issues with coding and had issues with understanding statistics. And one of the difficulties that we had was that with the teaching staff, we could mainly focus in the exercises on the coding issues, and that we did not find enough time to actually spend them to learn how to interpret statistics. And the idea was to try to embark into Dodona initially to learn them how to code in R. And that basically gave us rise to a kind of a first module with an introduction to R. And we developed a judge together with the Dodona team in order to be able to judge our exercises. At the start of the project, I got in touch with a colleague in the States who developed a book on data science. That's Raffaele Risari, and he had the whole book ready in R Markdown, and that was like a kind of an initial source that we could immediately use to convert it into Dodona. So the first course that we introduced was basically taking his course that was already in Markdown, R Markdown, and we only had to convert it into Markdown files in order to import it into Dodona. And the nice thing in Dodona is that at that time you already had both exercises that you can solve in R, or also reading exercises. And this allowed us to have both the course materials with small knowledge clips into Dodona, as well as the actual exercises. So we decided to have like this whole module on the introduction of R into Dodona, both the theory and the exercises. And this is how it looks. So if you basically go to it, you see that this year we had 295 registered users. So they also submitted a large number of exercises and solutions, something that we never would be able to sort out manually. And if you go through the course, you basically see that you have both reading reading exercises and actual exercises. And the nice thing with the reading exercises is that they can have small knowledge clips from YouTube that are incorporated into the course, and that they can basically follow the theory at their own pace. And after the reading exercise, they basically have to indicate that they have read it, and this allows me to see where students are in their individual track. And they can basically do it at their own pace, and that was very important for us because we have a very diverse set of students, ranging from biomedical sciences up to biology students and students from chemistry and geography. So we had like a very diverse set of students, and we also had students that had like a very strong curriculum in high school with a lot of mathematics, and students who had very few mathematics, and we see really the difference in how they develop their statistic skills. So they could follow that on their own pace. So this was very nice. We started with that in September 2020, and the idea was to just incorporate this course into Dodona, but actually it went so fast that the job student who was involved in it could migrate all the Markdown material in, I think, a couple of days into the platform, even with including the movies. So that was really impressive. And then we started to code up the exercises. Since we were in the pandemic situation, we basically decided not only to have like the introduction in R in Dodona, but also to have my entire statistics course in Dodona. And I tackled that in a similar way, and I will then show you. So I also tackled that with both. Wait, I will just go to the Dodona page. So I tackle that both with reading exercises. Here it's a course in Dutch, but also with the actual exercises. So it's very useful. You see that I have not submitted any solutions myself. So this is why I missed the deadlines, but you see that the majority of the students did. I used like a kind of a similar setup where I basically have knowledge clips who are using the theory that they need to have, and also the exercise material. And the nice thing with the exercise materials is that we were able to develop our own judge, and we also developed a judge that can judge both R code, but as well as plots. So if you use ggplot, you can also automatically judge your plots. And that was something that was extremely useful for us to help out the students with their coding. In the introduction to R, students basically learn to develop small R scripts, and they can just copy and paste the solutions from RStudio into Dodona. In this course, we also learn them how to work with R Markdown, and I will just give you an example of how we actually tackle that. If we go to the exercises, we have an example exercise here, and then students can download an R Markdown file that we already provide with a lot of content, and then they basically will have to develop R chunks themselves, chunk by chunk. And they are stimulated to do that in RStudio, because otherwise they start to think that the Dodona is to statistics. So they are stimulated to develop all the code in RStudio, and then they can copy and paste the R chunks from RStudio into Dodona. And in this way, in the end of the tutorial session, they have a kind of a complete R Markdown file that they can render to HTML with their own actual code. And this is how it looks like. They can just copy and download a kind of a half-solved exercise that looks like this. And then they basically have R chunks that are completed and R chunks that they have to complete themselves. And in the first part of the course, we basically already give suggestions, and later on the R Markdown files contain less and less information, and in the end of the course they basically can develop it entirely themselves. If we get through the exercise, they basically have different questions, and this is, for example, a question to make a plot In this plot, it was a plot on a pre-test, post-test design. So they basically measured the weight of small animals before and after they were banished from the group, and they wanted to see if there was a difference. And they had two sets of animals that were allowed to stay in the group and animals that were left out of the group. And the question here was to make a line plot where they have a plot with the weight before and after the banishing event, both for the animals that were taken out of the group and for the animals that were left into the group. So that was the question. And then they can just copy and paste there are codes, and they can evaluate that. And if you do that, we basically see that we now are making a plot. And you see that I have a wrong solution. I indeed have a weight before and after banishing, but I don't have it for the different groups. And you see that this was the expected output, and then we also basically indicate that they did not have defined a multi-panel plot, and then they can go back to the code, and then they can basically see, okay, I forgot to include a line of code. I forgot to include a line of code, so I basically have to include an additional line of code where I also make the plot so that I can do it for the two groups by using facet wrap, and then we basically see that we have the correct solution after we do that. And then they get the feedback that the solution is correct. And then they basically can continue with the exercise. That's the second part on data exploration. And then there will be also some multiple choice questions related to the design or related to the test that they use. And then they also have to assess assumptions and so on. So this is basically walks them through an entire data analysis. And the nice thing with this approach is that a lot of the syntax questions are already automatically resolved because they see that things are done in a wrong way and they get suggestions how to improve it. In the meantime, they can also ask questions to us in Dodona, and that's also very useful. This is an example of also anonymized questions in the module on the introduction of statistics of R. And then if we click, we basically have a question here of a student, what the difference is between the geom label and geom text. And then one of the research assistants have solved that. And they basically can annotate in the code their solution. And this is extremely useful because we were able to disentangle the questions related to statistics and interpretation and the questions related to the code. And we generally saw that the students improved much in both the coding and the interpretation for their statistics work. If you would like to use part of our developments, you can start with a new course, and as Peter already have indicated, you can reuse the developments that we have done so far by reusing our exercises. On the other hand, if you would like to include additional exercises, that's also a possibility. And the nice thing is that with Dodona, you basically have a GitHub page that is linked to the Dodona platform where you can develop new exercises. But I think that Bart and Peter will probably talk more about this integration and how you have to make new exercises. So people can use our developments as a kind of an inspiration. They can reuse exercises that we have developed so far. They can reuse the entire introduction to R, which is entirely in English, or they can use part of our developments in Dutch as well, if that's suited for your audience. And otherwise, you can also add or modify exercises in your own GitHub repository if you're a teacher. And we found that it's extremely useful. And we gradually migrated all our basic courses in statistics in this kind of format. And one thing that we did as well, and that was something that we started to do this year, is that we also started to leave out the conclusion sections, and that we now ask students to submit their conclusion sections separately, so that we can only grade the conclusion sections, and that we can focus on the interpretation. Because we have seen that with multiple choice only, students started to be lazy, and instead of thinking, they just started to choose multiple times the correct an answer until they had it correctly. So nowadays we also separate that again, but that reduced the workload for the teaching assistants enormously, because they only have to look to a small number of conclusion sections to see if students were grasping what they were doing. So that's
Thank you, Lieven.
now.
I'll take the word, but I think Bart will immediately join in. We already had some questions on how to add your own content to Dodona, so I think that's one of the things that Bart will highlight.
Yes, looking for the unmute button. Yes, okay. I will go off script for a bit because I saw a number of questions coming back, so I will recap some things to make it maybe more clear, and then go into creating your own content as well. So maybe one thing to recap is what is a course in Dodona? It's basically something you create that exists out of a bunch of exercises, and we group them in exercise series just as a way to group things together. How you use series is up to you. If you have an in-person course and you want to create exercises per session, you could use series for that. If you have a purely online course, you could split up your course in chapters and add both the instructions and the exercises per chapter or per subsection. So that's up to you. As Peter and Lieven both mentioned, so if you want to start using Dodona as a teacher, you have multiple ways or multiple levels of start using it. So the most basic thing is that you just reuse an existing course. So if I go to the more courses listing over here, you can see all courses on Dodona. If you select featured courses, then you see a number of courses that we think are of high quality or are great starting points to start your own course. We advise you to create a copy of an existing course for this, because if you use the course as is, then you won't be able to track your own students. So you won't have the necessary rights in that course, and all the students that are working in that featured course. For example, you can see here there are over 4,000 users who submitted an exercise in this one. So they're all together. If you want to work with your own group, your own class, it's easier to just create a copy, and then you will only see the results of your own students. So you can copy an existing course and use it as is. If you want to be a bit more creative, you can create a course from scratch. And if you create a course from scratch, you can build it up as you wish. And you can reuse any of the existing exercises in Dodona. And we have a whole bunch of them. If I go to exercises right here, we have a few filters. If you go to all exercises, you see all of them. And I think there are 30 or so on a page, and we have over 500 pages. So there are quite a lot of these in there. Then, of course, you can filter. You can filter by programming language, by natural language, for example, only show the English exercises in Python, for example, and then we sort them by how much they are used. So you can see which are the most used exercises, which are probably the ones that are of high quality. So you can create your course by using existing exercises, but you can also create exercises yourself. And as Peter typed in the chat, the way we let you create exercises is by adding Git repositories to Dodona. And in those Git repositories, you define your exercises. So you write the exercise description, you provide tests, you can provide example solutions, and so on. For more information on how to do this, we have a bunch of documentation. We have a documentation website, docs.dodona.be, which is in Dutch and mostly in English. We discovered yesterday that the tutorial I'm showing you now, no, sorry, this one is only available in Dutch. So we'll translate this to English as soon as possible. Right now I'm showing you a Google Translate version, but this goes through the steps of creating a new exercise from scratch. So it starts with the basic installation, asking for teacher rights on Dodona, creating a GitHub account, starting from a repository from scratch, and then what you have to provide in that repository. So each exercise lives in a directory, and that directory has a fixed structure. So we have a directory for evaluation, for the description, and for the solution. So if you're interested in creating your own exercises, this tutorial is a great place to start. Now, we already saw exercises in Python, and Lieven showed some in R. We actually support a whole bunch of programming languages. We have C, Haskell, HTML, Java, Prolog, R, Scheme, JavaScript, C Sharp, and so on. But this list can grow if there are people who want to add a new language. We can also help them in adding support for that language. I think I have a few examples queued up here. So for example, this is an HTML exercise where it's just a simple CSS exercise, and we provide some starter code here, and then they can submit, and a bunch of things are checked. For example, if the necessary HTML tags are present. We also have SQL exercises, which start from a database scheme, which is given, and then the student has to write a query which results or which returns described number of things. And for that, we also have specific feedback tables, which actually show you the results in a table form, and which also checks if the right things are in there, if it's sorted correctly, and so on. So I think that's were the most important things from me. I can still talk about learning analytics, but I think Peter covered the basics of those. But yeah, we have a lot of data, and we try to make the data available to teachers as much as possible through a number of graphs. Let me see if I can show you. For example, this is an exercise series. And if I click this button, I can see, for example, how much the user submitted. So apparently the second exercise, they needed a few more tries to get it right compared to the first one. We can also see a distribution of the status of the exercise. So here you can see that most of the submissions resulted in a runtime error. This can also be useful to debug your own exercises. And for example, if you can set a time limit in which the submission should run, this might be too strict. So for example, if there are a whole bunch of time limit exceeded submissions, then that limit you set might be too strict. We also have some graphs resulted to timing, so you can see when students are working. For example, this is from an evaluation, and yeah, not surprisingly, they started with the first exercise and then went on with the second one. We also have a line graph showing you how much or how big percentage of the students managed to solve the exercise correctly. So here again, you can see that they mostly started with the first exercise, and then once they got that correct, they started with the second one. Other statistics we have are on a course level. For example, you can see this is the statistics from Peter, his course. You can see that the lab sessions were on Monday afternoon and some on Friday afternoon. And you can also see those statistics for individual students. So this is from the same graph from a single student, so you can see when he or she worked on the exercises, both the time during the week, but also during the semester. So you can see that the students worked quite well during the semester, and then did some more exercises just before the exam, apparently. So that was learning analytics. Maybe the last interesting thing is evaluations. So Peter already told you we use this for exams. We can use the automatic feedback to grade the students, but mostly we also check the individual code and grade the submissions themselves. And we also build a feature around that, so you can evaluate a group of students. For example, this is the evaluation view for the same series I just showed you, with the same 2 exercises. And then you have a list of students who submitted, and they are color-coded. So the red students, or the students with a red icon here or with the red line, are the ones who submitted an incorrect exercise. The green ones are correct. And if I click and open the submissions, you can see that we see the submission of the code, and we here have a scoring rubric you can set yourself for each of the exercises, so to quickly grade the students. You can also add annotations to the code, so you can explain why something wasn't okay. And we have support for reusing those annotations. So if the same mistake gets made a lot, and you have to type the same annotation again and again, you can save it and reuse it later. And we're also working on reusing annotations more intelligently, so we can hint you at what annotation you might use for a selected line. But that's not something for the coming months. Maybe or hopefully next year we'll be able to bring this to production. So I think that wraps up everything I wanted to say. We have a few more minutes for questions.
Bart,
Thank you.
One thing that I forgot to say is maybe to indicate which different modules that are available. So maybe that's also interesting for people who would like to reuse our statistics developments. So we have a module on R basics. We have a module on programming in R. We have a module on tidyverse and a module on ggplot. And then for statistics itself, we have like data exploration. We have t-tests. We have linear models, ANOVA, multivariate models with multiple predictors. And we also have categorical data analysis. So we cover quite a bit.
Okay, sorry, here might it be a little loud, so thank you very much, everyone. So I opened the floor in the last couple of minutes, so please just open your microphone if you have some questions. And again, thank you to this very nice overview, the 3 of you. So who is a question? I saw there's already hundreds, of course, in the chat. So
I think we managed to answer most of them. So yeah, most content is.
I see here Wim.
Okay,
So
question. Wim.
Yeah. Please, Wim.
Yeah, hi. Thanks for the talk. I will lower my hand. I was wondering, so what do you recommend in terms of the students using for the initial coding? Like, because I know we talked about it, and you said that you use PyCharm and then they copy paste the code, or do you recommend in the beginning that they just use it, you know, do Python within this web framework? Because I'm just thinking about, you know, after they graduate from Dodona, they should also have a way to basically code themselves, I guess. So what's your view on that?
So my students are very much supported not to use the built-in IDE in Dodona for the exact reason you say, Wim. So if I'm teaching a group of students at university to program, my goal is that later on they can use their skills in labs and so on. So if they depend on the IDE of Dodona, they actually are too restricted in what they can do in terms of data analysis, so using the skills.
Yeah, and
So we held off from building the IDE in Dodona for quite a while, but the questions came mainly for secondary schools. So there's a lot of secondary schools now implementing programming, and there the friction is that either students use computers from school, or they use their own laptops, but the laptops can only have like a new image once a year. But if you do programming, it's not only about getting the right like your interpreter and your IDE, but you also want to use modules. So you constantly need to add new software, and if you don't have like admin rights to do that, you're stuck. And as a teacher, it's a lot of hassle to make sure that every student gets all the tooling on board. So we only have the built-in IDE for Python. So the one I showed you, and the interest for us came is because it's really cool technology. And normally in a browser, you can only run JavaScript code. But here we actually run a Python interpreter in WebAssembly in your browser. So there's no server-side component there. And so you have your Python runtime in your browser, which gives you all the features of like syntax highlighting, code completion, running, testing, debugging code. So that there's the debugger I showed you is also running purely client-side. And it automatically, as soon as you do an import, loads those modules in your browser. So there's no hassle anymore, but there are restrictions. First of all, it's only Python for now. And it's, for example, only Python modules with wheels. So that's all the NumPy, SciPy, Matplotlib, that all works. So you can do your plots in the IDE. But still, I think, especially for people working in research, people learning to code in university, the goal should be that students can use their newly acquired skills in the most flexible way. And then running your code locally, I think, is an important asset.
Yeah, with respect to statistics, it's the same. So for statistics, we also force the students to use RStudio because otherwise, yeah, they think that Dodona is for statistics, and that's not the purpose. So we also force them to actually submit compiled and Markdown files so that we are sure that they know how to deal with that when they leave university.
So maybe to answer James' question. So James, a little bit of explanation of what happens if you submit a solution to Dodona, but because that solution is evaluated server-side. Every time somebody submits a solution to Dodona, first of all, the submission gets in a queue. So there's never an overload in Dodona because we have peak moments where we have on average 4 or 5 submissions a second. So we have to just make sure that everything is stable enough. So the infrastructure is an important asset here, and is also secure, because if you have computer science students that have a platform that takes their code and runs it, they also try to breach it. So what we do is every submission ends up in a queue. If it's time to evaluate, but you saw this hardly takes any time, it launches a Docker container. So the Docker container is the runtime environment. In that Docker container, we add the submission of the student, the judge, so the component who is responsible for evaluating the submission, and it all happens in that Docker container. So if you have specific needs for specific modules or so on, that's something you add to the configuration of your Docker container, to the Docker file. So in the Docker file, you decide what operating system and what runtime tools are available for the students. So yes, for example, in the R judge has a connected R Docker. In that R Docker are defined all the R packages that are needed. Same for the Python judge, uses a Python Docker, and there's a restricted number of Python modules available. Or you need a judge that allows to download additional Dockers, by default, additional modules. By default, a exercise has a Docker that has no access to the internet, but you can connect you can actually have there's a configuration you can do and say, okay, my students need, for example, to download on the fly some data from a certain location. all that's an option. By default, we close it because everything you open is a possible security breach. But that, in theory, also adds the option to install modules on the fly. But one of the goals, of course, is that if you submit a solution, that students should see their feedback as soon as possible. We try to do that within a second. If you have to install modules on the fly, that takes time. So it's better to just do a pull request on the Docker container for the Dockers you're using, or adding a specific Docker for specific needs. For example, at a certain point in time, we had a specific Docker with a lot of bioinformatics tools. I'm head of computational biology, so I'm giving a lot of hardcore computational biology algorithms classes. So that's a lot of tooling in bioinformatics. So we used to have a specific Docker with these toolings and BioPython and all that stuff. But it was used so much that it's now just integrated in the default Python Docker. But sometimes we get questions from users saying that I want that specific module, and then we actually see if we just set up a new Docker or just add it to the existing Dockers.
Okay, thank you. Are there any more questions? I see some people already left because probably have other meetings, as it is again very busy in agendas.
Okay, but maybe as a closing remark, Alex, I think the important message is there's a contact page on Dodona. So if you need any help for getting started, we're definitely open to just have another MS Teams calls or Zoom call. It sometimes helps to bootstrap if you just, I think Wim can witness. He started a course this year in his university. I think we did half an hour bootstrapping Teams. And then if you have questions as a follow-up, either put them in the contact page or actually the contact page is just also a wrapper to our email address. It's dodona.be.
So maybe you can share this again, indeed. Thank you, Peter. Thank you, Bart and Lieven, also for your very nice explanations. I think it is very, very powerful, as we saw, and it is yet to be a lot of things to be discovered, I see. And since you have your software developer now also in the team, I think we can expect more things in the future. So again, thank you. I think we can round up here and with the very welcoming offer from Peter. So if any of you has the need or wants to step into Dodona, please reach out. Thank you, everyone, for joining. Bye-bye.